Today we're going to talk about the topics that's near and dear to my heart, one that helped me gain some acclaim within the identity management community, the care and feeding of Microsoft Identity Manager databases. Our goals here are to help you have faster performance with MIM, better reliability, and of course job security. The challenges you may face is that you may not have a DBA assigned to the project and it may be all up to you. Or if you have DBAs, they don't understand your special needs. What are your needs? Some of these things DBAs are going to know are general purpose, but we'll also talk very specifically about MIM. First up, tempDB. Make certain it's set up properly, otherwise performance in MIM will be terribly slow. We also need to know where to put our files, the data files and the log files. We need to protect against corruption. We need to do proper backups, and we need to do index maintenance. tempDB, what are its uses? Well, it's used for sorting, much like that space on your floor or your couch where you take your laundry and you dump it out so that you can sort it and fold it. tempDB is kind of like that. You use it for sorting, for index rebuilds, for big queries, for temp tables, for row versioning, and that is very useful for triggers and for snapshot isolation levels. Concepts you may or may not have heard of, that's okay. The important thing is, if you don't set up tempDB properly, performance will be slow. So how do you do that? I'm glad you asked. Here are the recommendations. You need to set up quite a number of tempDB files. So we look at how many cores you have. If you have a bunch of cores, you should set up for every 4 cores you have, you should set up at least one tempDB file, maybe up to 1 out of every 2 CPU cores you have, up to a maximum of 8 tempDB files. That's for the data files. You only need 1 tempDB log file. Ideally, you should separate tempDB data and tempDB log on different disks, but if you're putting this on a solid state drive, that doesn't matter. They can go in the same place. There's a couple knowledge base articles I call out. One that says, please don't shrink tempDB. That'll hurt your performance. And another one that talks about how to move tempDB. We also need to size tempDB properly to begin with. This here is a report that's found inside SQL Server, the disk space usage report. And it shows us a database here that has a lot of empty space and that the transaction log is also relatively empty. And you can see that we have quite a number of data files for it. And most importantly, you see right here in the middle, no entry for autogrow/autoshrink event for tempDB in the trace log. That simply means that since the last time the SQL service was restarted, it doesn't have any record of tempDB requesting an auto growth. Why is that important? Well, auto grow is a timely process, a time-consuming process. And when tempDB has to auto grow, there's a couple things that happen. One, the tempDB can grow in fits and spurts all across the disk. For another, there's the time it takes to grow the tempDB files, either the data files or the transaction log file. So these are things that you don't want to have happen right in the middle of running a synchronization or people on the MIM portal trying to do things, trying to update a group, and it needs to process stuff and it needs more room. So those are things that we want to avoid. It's okay if you see that your tempDB data files and transaction log files are sitting there unused most of the time. That's what we want. We want it pre-sized for peak times. One other note about the item here is that tempDB, it gets recreated every time you restart SQL Server service, which means that if you don't size it properly and you just count on auto growth, when it restarts, it's going to go back to where it was. And it's going to have to go through the same painful auto growth as before. So, size it properly to begin with and save yourself some headaches. When changes happen in a database. The data needs to be put in the data file in its proper place, much like a librarian putting books in their proper place on the shelves. Since writing to disk is much slower than accessing memory, SQL Server does this updating in memory, in RAM, and then every so often, about 60 seconds, it issues a checkpoint and writes or flushes those changes to disk so that they're preserved. But what happens if the computer loses power before it has a checkpoint? Some of those changes might be lost and our data corrupt. To avoid that, the changes are written immediately to the transaction log. But here it's done as fast as possible, like a court stenographer, noting everything down in a serial fashion without taking time to sort or catalog. This means that the transaction log files and data files should be on separate disks to reduce contention. Of course, if you're using a solid-state drive, then that doesn't matter as much since they're almost as fast as RAM, and much faster than the older magnetic physical disks. Additionally, with the transaction log, you should bear this in mind. So it gives the SQL Server reliability, recoverability, and speed. So our data is going to be more reliable. In the event of a disaster, we can recover right up to the moment in time, depending on a couple other things we'll talk about later, recovery model. And it allows SQL Server to be much faster than it would otherwise. For every database, you only need to have one log file, and as I mentioned, it should have its own disk. And you probably want to think about putting it in a RAID 1 scenario so the disk is mirrored. So that if you lose one of the disks, you're still good. Now, what happens when files grow? When your database grows? Well, one thing that can happen is that the table scans increase and your index seeks decrease. And some of you may be looking at me and this presentation going, I don't know what that means. Talk to me in English, David, not SQL Greek. I'll get to that. The other thing that can happen is page splits. Pages get out of order. That's external fragmentation. There can also be empty space inside pages, known as internal fragmentation. Give you some examples of those two. So first, the table scans. So a table scan, that's like this little girl or boy having to read every single page in the book in order to find what they're looking for. Versus an index seek, like out of the back of my book, How to Be an MVP in Life, where you can look something up. Oh, David talked about the Atlanta Braves quite a lot. What pages was that? Page 11, 37, 51, 82, 91. That's much, much faster than having to read all 125 pages of the book. In computer world, the difference is also several orders of magnitude between having to read every page in the table versus being able to navigate right to it. The query optimizer might still choose to avoid certain indexes if they're beaten up or out of date. So it can still choose to do a scan. And as I said before, that means it reads every page in the table. You can see how many scans are happening by looking at the performance monitor counter, access methods, full scans per second. You should ensure that auto create and auto update stats is enabled so that the query optimizer knows when indexes are out of date and knows which ones to use and can make a wise decision, because sometimes it is better to do a full scan than to use a particular index. I promised an explanation about external fragmentation. This will also illustrate a little bit of internal fragmentation. So, in SQL Server, tables and indexes are stored in pages. Each page is 8K bytes, so 8,192 bytes. And these are in turn grouped into extents. So 8 pages make an extent, or 64K of data. And so there's an extent, and then there's another extent. So in this case, we have at least 101 extents in this table. Inserts can cause a split. So if I have a page that's full and a new row is inserted into page 3, that will cause a split. A new page has to be allocated, and that new row and some of the other data from that page gets moved to the new page. we now have empty space. Page 3 and page 4 are now approximately half full. The empty space inside the page is known as internal fragmentation. But now page 3 and page 4 are far apart. Extent 101 wasn't full yet. It only had, up to 7 pages. There was room there for another page. So now instead of being perfectly in order, page 4 is way out of order. So this is known as external fragmentation. To track how often this happens, you can see the performance counter, SQL Server access methods, page splits per second. The first time you look at it, it might be alarming. Fragmentation. What's the consequence of fragmentation? Searching and inserting take longer because the index becomes deeper, and pages are out of order because of the page splits. So the index is fragmented. Pages are partly empty, and because of the updates, the deletes, the page splits. And then here's a query that you can use to look at and see how bad the fragmentation is in your database. This one is looking at a table that is notorious for getting full and notorious for having bad odd items, bad fragmentation. It's notorious for having bad fragmentation. It's the step object details table in the FIM synchronization service database. Every time the FIM synchronization service database imports, synchronizes, or exports any object, each object gets a row in that table. So if you don't clear out your history, that will become the biggest table in your database. And it might still be, depending on how often you're cleaning out your history and how much you're keeping. Okay, when we talk about indexes, there's another concept that we need to understand, and it's called the fill factor. This says when we're going to reorganize an index, how full are we going to make it? Are we going to leave a little bit of space so that if we have an insert that needs to go into page 3, it doesn't have to do a page split? So this is one of the ways in which we can avoid page splits, is leaving a little bit of empty space. Too much empty space and the reads become inefficient, because then you have to read 8K off the disk to only get 4K of data. Not enough memory, not enough space in there, then the inserts and updates cause page splits, which take a little bit of time. Even worse, that page split can result in having to grow the file, which takes even more time. Both your data and log files will probably need to grow. You can pre-size things, and I recommend you do. But you should still set up auto growth so that it will grow. You'd rather have growth take place than to have the FIM synchronization service throw up its hands and say, I can't do anything because there's no room in the log or the data files are full. But again, the auto growth is expensive and hurts performance, which is why you want to pre-grow your data and log files when possible. So you make a guess at the beginning how big it's going to be, you set it up that way, and then you monitor, and periodically you look at it and go, oh, yeah, we should probably grow that a little when we're getting 50, 60, 70% full. We'll talk more about log file growth a little bit later when we talk about recovery models. Hey, it's later. Recovery models. There's 3. The full recovery model, the simple recovery model, and the bulk log recovery model. Recovery models interface directly with backups, and so we can't talk about one without talking about the other. But let's talk about what these do mean. In the full recovery model, we write everything to the transaction log, and we keep it there. And so that transaction log gets bigger and bigger and bigger and bigger until we back up the transaction log or truncate it, which means just throwing that away without backing it up. If we back up the transaction log, that gives us a lot of flexibility when we have to restore. We can actually restore right up to a particular moment in time and stop it right there. So that if I knew something bad happened to the database at 10:31 p.m., I can stop the transaction, the restore the transaction log backup at 10:30 and 59 seconds. So the full recovery model takes up more space on disk, but it gives you the best flexibility when it comes to recover. The simple recovery model is only as good as your last full or differential backup because it gets rid of the transactions every time it does a checkpoint. It also doesn't log what are called bulk logged operations. There are certain kinds of operations like truncating a whole table or doing a bulk insert that it doesn't log. So the simple recovery model is great for dev environments where you want to be low maintenance and you don't want to have to worry about backing up the log and having lots of disk space. Just throw it in simple. But in production, you're probably going to want to usually be in full. But every now and again, when you're in some kind of maintenance window or you're trying to fix a problem, like you're trying to clear out the transaction log and start your backups over again, you'll need to switch to simple recovery model. That is, in fact, how we truncate the transaction log without backing it up. There's another recovery model called bulk logged, and it should really be called the non-bulk logged or anti-bulk logged, because bulk logged recovery, that's all, folks. The bulk logged recovery model does not actually log the bulk logged operations. It keeps everything else until we do the backup or the truncate. So generally, you would only want to use the bulk logged recovery model when you're going to do something that is bulk logged and you don't want to make your transaction log go and blow up like a big puffer fish. For example, we can speed up index rebuilds by switching to the bulk logged recovery model. Okay, so now backup types. We have 3 backup types: the full backup, the differential, and the log. The full backup copies all of the data pages, and it only grabs items from the transaction log that happened during the backup. Whereas the differential, it only copies data pages that have changed since the last full. And it also grabs transaction log items that happened during the backup. The transaction log copies the entire transaction log during that backup and truncates all inactive transactions. It's the only type of backup that actually truncates the transaction log and frees up that space inside the file. You cannot do a transaction log backup if you're in the simple recovery model, because the transaction log only has active transactions. Anytime you get to an inactive transaction and you have a checkpoint, it wipes those out of the transaction log. So we have our recovery models, full, simple, and bulk logged, and then we have our backup types, full, differential, and logged. So which one should you do? The system databases, master, MSDB, and model, you should do a full backup. I recommend doing that every night. Your user databases, oh, what about tempDB you said? Ignore it. It's tempDB. You don't need to back it up. What about user databases? User databases should also have a full backup happen. How often? That depends. There are some organizations that do a full backup every night or more than once a day. Part of it depends on how big your database is, how fast your backups run, and whether you're willing to take a performance hit in the middle of the day or not. Generally speaking, I see the FIM synchronization service database and any staging databases backed up full on a nightly basis. If things are really big, you might do a differential every night and a full on the weekends or some other non-peak time. A log is a must. If you're in the full or bulk logged recovery model, you must back up the transaction log. Otherwise, that file will become bloated. So you should have a regular routine for full backups and log backups. What about differential backups? You can do this. You don't have to, but it can speed up the recovery process. How, you might ask? Well, if I have a full backup at midnight, and then I do a log backup every hour, and I do a differential backup every 3 hours, I can skip. If I have to do a restore, I can skip a lot of the differential backups. I can just skip over them completely. So I can restore my full backup, I can restore the latest differential, and then any logs that happened after the differential. So if I have a failure at 9 p.m., without the differentials, I would need to restore my full, and then I need to restore about 20 backups, 20 plus log backups. But with the differentials, I would just restore, if I got the differential at 9, I restore that, and then the log. If I got the differential at 6, I restore that and any subsequent logs. So differential can speed that up quite a great deal. Which recovery model should you be in? Talked about this just a moment ago, but for the FIM synchronization service, you should be in the full. You could switch to bulk log during index rebuilds or some other, you're not doing any other bulk operation to the FIM sync service, so just during index rebuilds. But a staging database, you could do switch to bulk log during some kind of bulk operation. When should you be in simple? I recommend it during initial load. As you're loading your data up initially, it'll make things go faster. FIM service, same thing. Ditto, ditto, ditto. Log file growth. It is going to depend on the size, the number of transactions, the recovery model, and your backup schedule. If you're doing log backups every 3 hours, then your log is going to be, will need 3 times as much space as if you were backing up every hour. And again, I can't emphasize this enough. If you're in bulk logged or full and you don't back up the log, your log will get large and much larger even than your data file. You should monitor the performance counter, SQL Server, databases log growths to see how many times your log has to grow. I do recommend that you pre-grow your log file. I recommend that you set it to at least 1/4 of the estimated total size for your data files. And I have something in the book to help you estimate how big the data files are. Okay, something else about transaction logs that affects your performance is VLFs, or virtual log files. Whenever you add space or the log file auto grows, it's going to create new virtual log files. So the transaction log is divided into these virtual log files. If you're adding or auto-growing by less than 64 megabytes, it's going to create 4 new virtual log files. Ideally, you want to have around 20 virtual log files for best performance. If you have too many, you get poor write performance. So you want to have, between 20 and 50, but the ideal is around 20. If you have, if you grow less than 64 megabytes, it creates 4 new virtual log files. So they're each going to be 16 megabytes or less. If you grow greater than 64 megabytes but less than 1 gigabyte, it creates 8 new virtual log files. So taking however much space and dividing that by 8. If you grow in increments of greater than 1 gigabyte, it creates 16 new virtual log files. And what happens is, as it's writing to a virtual log file, it fills up one before it moves on to the next. Also, the log backup doesn't clear a virtual log file until it's moved into the next one. So if I have a small number of huge virtual log files and I go and do my log backup, my transaction log might still seem like it's got a lot of stuff in there. And I'll be going, wait a second, David said that the log backup truncates the transaction log. But he's a liar because I still have tons of space being used there. Not so. It may be an issue with virtual log files, that you may have too few. But again, put too many and you get poor write performance. So again, the ideal is between 20 and 50. When you get to 50, you definitely should trim it back. So how do I keep an eye on this thing? Oh, here's a performance test from Lynchy Shea on SQLblog.com. The insert test when he had a small number of log files versus a large number of log files. And you can see how long it took. So that inserting, updating, and deleting took not quite an order of magnitude, was not quite an order of magnitude better when he had a smaller number of virtual log files than a larger number. I've got a query that'll be that's available on my blog for how to look at the log space. My blog, for those who don't know, is ilmbestpractices.com. Also fimbestpractices.com, mimbestpractices.com. So you can go there and you can find my blog and you can query for this. And it goes through and it'll help you see the virtual log file sizes. How many there are, what's the max size, the min size, the average size. Because they can also vary in size. So if I'm sideways on this, what do I do? If I have too many, wait for an inactive time of the day. Ideally, you'd want to put the database in single user mode and clear all your transaction log activity through a regular T-Log backup. If you're using the simple recovery model, you don't need to do a log backup. You just clear it by making certain there's a checkpoint. Then you're going to shrink the log to as small a size as possible. And then you're going to grow your database, you're going to alter the database to modify the transaction log file to the appropriate size. And then you can run dbcc log info, specifying the database name, and you'll see how many virtual log files you have. Okay, now it's time to talk about maintaining our indexes. This is a flowchart based on data provided from the Microsoft SQL Server product team. If we have an index with less than 1,000 pages, so if it's less than 8 megabytes in size, then don't bother to do any maintenance. A scan is actually faster than even having indexes. It's a waste of time to even have an index. If it's more than 1,000 pages, and the average fragmentation is less than 5%, then don't worry about it. It's not worth doing any kind of index maintenance. If the average fragmentation, however, is greater than 5%, but less than 30%, then we can do a reorganization. I'll explain the difference between these in a moment. If it's greater than 30%, then we need to do a rebuild, which is bigger. Let's take a look. A reorg focuses on the leaf level, whereas a rebuild rebuilds the entire index, the whole tree. There's another thing that happens, which is updating stats, where it comes along and it does a sample to build statistics. So the optimizer, the query optimizer, knows what's the best way to go. Do I use this index or not? Do I use a different one? And the statistics do get updated during a rebuild. To take care of all of these needs, I highly recommend the SQL maintenance solution from Ola Hallengren, who is a SQL Server MVP. I'm sorry, they've rebranded all that. Data Platform MVP. And has won many awards for his solution. And his solution itself has won many awards. So Ola Hallengren's maintenance solution consists of several components. And we usually create this in the master database, but you can create it in any other database you want. It creates 7 jobs, and it creates 4 stored procedures and 1 table. It creates a command log table. It creates a command execute stored procedure, a database backup stored procedure, database integrity check stored procedure, and an index optimize stored procedure. And then there's 7 jobs for doing backups, integrity checks, and optimize. The backups are separated in a couple things. First, you'll notice that there is a database backup system databases full, and then there's a user databases diff, a user databases full, user databases log. Ola doesn't know which solution, which recovery model you've gone to, so he's giving you the flexibility here. And if you do try and run the log backup against a database that's in simple recovery model, his solution's smart enough that it just skips that. Then there's database integrity check for system and database integrity check for user databases. Wait, what's that? You want to know why there's not an option to do a log backup for the system databases? A couple of reasons. One, the system databases actually are kept in the simple recovery model, so you can't do a log backup of them. 2, the system databases are really small, so there's not really any point in doing a differential or log to them. They're just, they tend to be small. Okay, so system integrity checks, we do need that. That is important to check the system databases as well as your user databases, looking to make certain that the pointers to the pages are in the right place, that it hasn't lost data. SQL servers become really good at keeping an eye on that, but you have to run those jobs and look at the results. Index Optimize is one of the great key things that I love about this solution that's better. All of these are actually better than the out-of-the-box things that Microsoft provides for you. And even though they've improved them over the years, they continue to be better, which is why I continue to recommend Ola's solution. As I mentioned before, in that flowchart, less than 5%, don't do anything. Greater than 30%, let's do a rebuild. In between, let's do a reorganize. So in the index optimize, there are these three parameters: fragmentation low, fragmentation medium, fragmentation high. On the fragmentation low, the default is nothing. Fragmentation medium, the default is index reorganize. If that's not supported, do an index rebuild online. If that's not supported, do an index rebuild offline. There's some operations that aren't supported for particular kinds of indexes. Generally speaking, the index reorganize and index rebuild online are supported by the indexes used inside MIM. Fragmentation high, the default is index rebuild online, index rebuild offline. So again, it's a fallback. Tries the online. If that doesn't work, then it does the offline. Here's a look at all the parameters available to you. It has a ton of parameters. There are a couple that I do care about. We'll talk about in a moment. So Ola has exposed all of the parameters that you need here so that you can set it up. And you can even create multiple jobs or use the same job with multiple steps if you wanted to handle different databases differently. Here are the two parameters that I recommend overriding for MIM. Wait at low priority max duration equals 2, and wait at low priority abort after wait equals self. These two parameters work together. The first one says, if we encounter an index that's locked, we're going to wait 2 minutes. And we, meaning the index optimize process. And then the wait at low priority abort after wait says, what do we do after we've been blocked for 2 minutes? And you can just keep waiting, or you can abort your own index optimization process for that index, or you can kill the blockers. You can kill the transactions that are blocking your rebuild. I recommend self, so that if one night, an index is being locked because there's operations going on, then you skip it and you'll pick it up the next night or the one after that. If the index is rebuilt, Ola Hallengren's solution skips updating the statistics, which is nice. It will also deal with only the modified statistics when it goes along and updates things. The database backup procedure has all of these stored parameters. I'm not going to go through them all, but you will note that it exposes all of them, including compress. Okay, in database integrity, Ola Hallengren's solution, it's capable of dealing with the availability groups. It can handle the read-write status of databases, the extended logical checks, file groups, and it can also have a lock timeout. Here's a look at its parameters. So in summary, tempDB, give it enough files. Okay? Separate your log and your data and pre-grow them. Choose a recovery model appropriately, most likely full. Occasionally you might switch something into bulk logged, like when you're doing database index optimization. And check for integrity. Set up an appropriate backup strategy that's going to include fulls and either diffs or logs. If you're doing full recovery model or bulk logged recovery model, it must include logs. You must do log backups. And finally, use the Ola Hallengren solution to optimize your indexes and to take care of the rest of these things for you, the integrity checks and the backups. Since that was clearly one of the more superior technical how-to videos you've ever seen in your life, I highly recommend you check out our latest video, our playlist, and subscribe.